people and then call the presenters later. That's it. Yeah. Okay. Hello, please call everybody. This one. Hello. Call everybody. Welcome you all to the fifth Decentralized Energy 2011. It's the fifth seminar in the series. Sorry, fourth Decentralized Energy. I'm still on the hangover of the award. So we had the first three in Mumbai. It's the MMR region. And we have now brought it to Delhi because it's important to realize that we are going to have a great challenge in rescuing ourselves from the power shortfalls that we have, especially the urban sector. So today we have amongst us Mr. Anil Rajdhan, who is our presiding guest of honor, the former Secretary of Power, and also the former Special Secretary for Petroleum and Natural Gas, India. Please give him a big hand, please. Because he's for the first time coming to a decent energy seminar of ours. May I request Mr. Rajdhan, and I would also request a few of our guests who have come to come for the lighting of the lamp ceremony. The energy must not die down. More energy. Please give Arora sir a big hand. Marcus. With that, we declare this open. To begin with, I will request Rajdhan Sahab, our presiding guest of honor, to come over. Mr. Dinesh Parekh, President Thane Bilapur Association, to come on the dais, sir. May also request Dr. Hirdesh Khanna to be on the dais. And may also get Mr. Rajesh Shah. Rajesh Bhai, you are required on the dais. And also Mr. Sunil Shahi to join them. Mr. Sunil Shahi, please. There are a couple of other presentations, and I will request the speaker to join us later. So welcome all. Mr. Shah, please. Rajesh Bhai.
I represent 4,500 manufacturers of New Bombay.
So may I again introduce our distinguished guest. Mr. Anil Rajdhan is the former Secretary of Power, Government of India, and also the former Special Secretary for Petroleum and Natural Gas. Mr. Rajdhan is one of the most dynamic secretaries that we had in the Power Ministry, and he changed a lot of things that happened in the, I would say, last 3 or 4 years. If you see the impact of what his tenure was. You'll see a lot of dynamism that has entered the power sector, and we are right now in a transitional mode to perform better. So, we must give him a big hand for. And we have Mr. Dinesh Parikh, one of my very good friends and a person whom I admire, a very, I would say, dynamic industrial association president in the country. By the way, Thane Belapur area is the largest industrial area in the country, and he's the president of the industrial association. Please give him a big hand. We have also amongst us Dr. Hridesh Khanna. Dr. Hridesh Khanna happens to be one of the best experts in the area of decentralized and distributed power and gas-based technologies. He heads MTU on-site energy business, operates from Germany as well as Singapore, and he's been credited to have succeeded in India in a lot of new decentralized smaller power plants. And just about 4 days back, MTU on-site also won the Inertia Awards for decentralized and distributed power. Please give a big hand to them. We have Mr. Rajesh Shah. Rajesh Shah is again an old friend whom I knew from the days of Thermax, and he operated in the area of energy, waste heat recoveries, and later on moved towards cogeneration and combined heat and power. He headed Turbomac, and now he's the president of Sterling and Wilson. And he's a man who knows a lot about decentralized distributed power, and also he was instrumental in the DLF 70 megawatt, the technology that's provided the back. I would say the backing that is provided to that system. He's been responsible for that. He knows quite a bit about how large-scale decentralized distributed power can be brought into the country. So basically, that's the idea. The idea is the moment that shift happens, that you don't approve electricity connection, number one, to such projects. Number two, you don't allow them to operate with diesel because it is the subsidy which will be used up for commercial operations. So that goes, immediately we see a chance for gas. And third is there must be a way to tell our gas suppliers a kind of mandatory situation that it must not be for large power plants. I'm sorry, I don't want to name them, but very large operators who would probably never come up, many times don't not even acquire the land, while gas is being allocated on paper to them, ends up giving nothing to the country. In fact, a small, I would say decentralized situation of aggregate of these power plants on gas in the country can make huge volumes and also makes business sense and comes onto the grid with better efficiency and lower costs of the tariff of power, So now I request with these ideas Dinesh Parikh, President, Thane Belapur Industrial Association, to address us on these issues and also on the topic of the day, how decentralized distributed power can come up for industrial estates.
Respected Razdanji, all the eminent panel members, Professor Iyer, and all the competent and critical executives taking part from various walks of life in such an important subject of the day, and how to resolve power supply crisis for our country and country's 8% growth. Friends, my name is Dinesh Parikh. I represent 4,500 small, medium and large industries of Navi Mumbai called Thane Belapur Industries Estate. Growth is tremendous. The land price was 300 rupees a meter just 10 years back. Current price of land is 50,000 rupees a meter. Now you can imagine what a great demand for land to establish manufacturing units. Demand is jumping, requirement is acute, supply is warranted. Government is not geared up. Government has started 2 brand new plants. And as usual, the state government and some of the officers are quite concerned. So they started brand new 2 plants called Paras and Parli, which were supposed to make 600 megawatt each and supply to the industry in the Maharashtra state. As Razdan Saab said, the efficiency level in government always goes down. For a very strange reason, both of them are working hardly at 50% capacity. Earlier we used to be supplied by 1500, 2000 megawatt in Maharashtra state. The current figure I've heard is 5400 megawatt. And Professor informs me that it's bigger. Maybe government is misguiding. It is more than 6,000 megawatts. Now what to do? This country is having all the competent people, scientists, administrators, consumers, manufacturers of various products, all the eminent faculty sitting on the dais, and you such people who understand subject inside out. How come as a group we are not coming together and pressurize our government, energy department, and not improve the scenario? We all know that along with generation of electricity, we all have to look after environment. There are so many laws coming up through MOEF on various aspects of industry as well as residential areas. That unless you balance the generation and control the system by which pollution is constantly being reduced, either of them will not be in balance with each other, and overall mankind won't be able to afford either our technical progress or industrial progress. You know, as Dr. Mashelkar says, we require different type of thinking on the subject. We don't have to think about bigger plants and same technology. I heard a wonderful example that he mentioned recently in Bombay. That laptop was manufactured and sold around 1 lakh rupees 10 years back. Everybody bought it. But what about millions of very bright Indian scholars, students from rural areas? They cannot. Like 1 lakh rupee for one instrument in study was too much for them. So they threw challenge. It seems that our then Prime Minister threw challenge to Dr. Mashelkar, who is the chief of scientist pool of our country, that you get me somebody to invent a new technology, new model, but reduce the cost drastically because country cannot afford such a high price. The challenge was thrown open, and I was told that one scientist from Pune, Mr. Deshpande, invented similar laptop for less than 10,000 rupees. What needs to be counted right now is not how we produce, what we produce, at what cost we produce and give it to the people at a very low cost. Consistently with quality supply of power. The main challenge is, can we reduce the cost? Is there any new technology available? Is there some scientist amid us who can find altogether a fresh thinking and not go through the conventional route? Now I'm told one IIT boy in Bombay has invented a laptop which will be less than 1200 rupees. I think human mind can resolve any issue which is existing amidst us. The routine thinking that first you put 1 megawatt, then 10 megawatt, then 100 megawatt, size keeps on multiplying, the quantum keeps on multiplying, is not the only way we are going to succeed. This big project, long pipeline, long transmissions and distribution, we are seeing the fruits in Bombay. Though government officially says that 30-35% power is being stolen, it could be more. Indian people under the competition and poverty has started becoming criminal to ensure that they survive in competition as well as in their day-to-day life. And quality of life, everybody would like to upgrade. I was told earlier, before privatization took place and Torrent company came to Delhi, even minister's bungalow used to steal power by putting 2 hook and then running 12 air conditioners. It's human nature. People want everything, but at a reasonable cost. In industry, we are also saying, change your product processes, manufacturing processes, change your method of making those articles, change your fuels, change your raw materials, but find out a process which is most economical so you can sustain your production. And very large number of Indian people can buy your goods. You know, for import bill, when we read it, how much petroleum product we're importing is unbelievably getting inflated larger and larger. Rajdhanji just said the supply is finite. Then how long we are going to last? Or do we want to kill our future generation without energy? I recently went to Korea, South Korea. Efficiency in every walk of life will lead to lower cost and better quality and consistent supply. I'll just tell you few small things that we observed, which must be saving millions of units to their country. In supply of good quality, consistent power to industry and the society, and we all can have a quality life and good standard of living for our children and grandchildren. I appreciate being invited. I wish some one of you will make a miracle in power generation and distribution, and someday I should read shortly that Nobel Prize for Power came to India and Indian scientists. Thank you.
Next, may I request Dr. Hridesh Khanna, Director of Business Development and Strategy, MT On-Site Energy, to give us his keynote address on gas-based decentralized power solution for India's urban power crisis.
Good afternoon, ladies and gentlemen. Professor Iyer, thank you very much for giving us this opportunity today to discuss the emergency needs and what we have heard from our distinguished speakers before me, the gas scenario in this country and the problems associated with them, plus the need to grow, the growing demand from the industry. So the topic today is 50 gigawatts of gas energy and in a decentralized basis, and what can we do. But before we address that, I think some of the issues which my previous speakers mentioned was a mix of certain problems which they were mentioning over here. And I think if we look at the basic needs of the humanity today, the mankind, it is clean water, clean air, clean environment, and clean energy. So all these issues require in some form or the other energy served in an efficient manner. But before we get that energy in an efficient manner, we have to also look at the resources which are available today. And let's say, first of all, if we need power, power means 50 gigawatts, and the resource which you will be utilizing for that 50 gigawatt as electric power today, taking an average efficiency of roughly about 40% to convert that resource, we require 250% of that resource, which means 50 gigawatt will become more than 100 gigawatt of resources which we will require. So my first address would be to save energy wherever it is possible, because if we save energy, then we can reduce the size of all these huge big plants. We can reduce what the transmission requirements are concerned, and there comes the concept of the distributed power. So I would like to address these complex issues in a certain manner, introducing also a little bit about the Tognum Group, what they are doing today, how they are innovating technologies in various fields, plus the energy area, which again my previous speakers mentioned and Professor Iyer also mentioned. This country, one aspect is the urban requirement, the other aspect is to have the electrification in the or energy supply in the rural areas. If you make energy cheap, people will waste it. If you make it too expensive, people cannot utilize it. So we need a very intelligent mix of the energy conversion and energy generation today, you see. And that is where the innovative aspect comes into the energy part, which technology can only serve based on new developments, and this is what we are doing. So Tognum basically is a company which was owned by mainly by Daimler-Benz, and now it is owned by Daimler-Benz and Rolls-Royce. And these are two very, very big names in the world, but they have a commitment to the market, and the commitment is to develop technologies which are useful to the mankind, and this is what we are going to do in the engine business. So I would like to start my presentation with a small overview of the Tognum Group, what they are doing, and then later on I will come to the solution part, showing some of the solutions which we are doing on the power sector, in the energy sector, and what we have done worldwide and also in India. So maybe we can start with the film on Tognum.
Please give me the volume.
Covering hundreds of kilometers is part of our routine, on water and on land. And whenever it's our job to deliver them, power and heat will always be available. Where the power actually comes from is something we rarely stop to ask. The power behind it all is Tognum.
People often ask me, what's Tognum? Tognum is the ultimate specialist for propulsion systems and distributed energy systems, based on diesel and gas engines.
Tognum unites three strong brands: MTU, MTU On-Site Energy, and L'Orange. MTU engines and propulsion systems can set even the heaviest machinery in motion anywhere on the globe. Injection technology from L'Orange makes engines cleaner, more cost-effective, and more powerful. Distributed power generation solutions from MTU On-Site Energy ensure a fail-safe supply of heat and power.
We've set the standard with innovative solutions, now and for the future. We develop system solutions, standardized or customized, all from one source.
We invest in new and sustainable technologies that make our products powerful, economical in their use of resources, reliable, efficient, and more importantly than ever, environmentally friendly. Our diesel engines already meet future emissions requirements. Fuel injection, turbocharging, electronic engine control, and exhaust aftertreatment are our key technologies, and they work in perfect harmony. All our know-how is generated in-house.
And we continue to gain the technological edge for our customers and for the environment.
Over a century ago, Karl Maybach laid the foundation for the Tognum Group in Germany. Today we have design and production facilities in Europe, America, and Asia.
It's really cool to see just what our engines are capable of driving, and that we can generate power anywhere on the globe, at any time if needed, even when other generators fail.
Our products are in many different markets all over the world. We cover the full performance spectrum. Our strong team spirit helps us to create the very best solutions in propulsion and power generation. We place a high value on the experience of our long-standing employees and the fresh ideas brought by upcoming generations. And when the finished product leaves our factory, our job is far from over.
We provide service to our customers from a network of 1,200 locations all over the world.
We dispatch spare parts within 24 hours.
Service teams are always ready to help, on site or even by remote diagnostics.
We remanufacture engines and components to the highest technical standards, returning them to as-new condition.
We make sure that whatever has to function does. Tognum is the power behind it all, a power which can be relied upon. The power of our ideas inspires us to think ahead, to be ahead. Tognum is the power of the future, for the environment, for our customers, and for our children.
That was a little bit of an introduction of Tognum, and to give you a little bit of some interesting movies. Now I'll show you the solution part of it, the presentation. So you have finished my cards.
No, that's I will find it. Just to skip in it, please, sir. When you come to Bombay, do let me know. Thank you, sir. Have a good day.
As you see, we started about 100 years back, 1909, now it is 2011, that means 102 years, where we started as a small company manufacturing engines for the air industry. Then came Maybach, which is a renowned brand, which was the father or the mother of the Daimler companies, and later on the Maybach Motorenbau with Daimler-Benz heavy-duty business. So formation of Maybach, Mercedes-Benz engines, Motorenbau is engines actually, but that's the name actually of the company. Merger of Daimler-Benz and MAN, heavy-duty diesel engines and jet engine businesses. Then formation in Friedrichshafen and Munich of the company, the group MTU. That means Motoren and Turbinen Union, so turbines and engines together. MTU in 1985, MAN sold MTU shares 50% to Daimler-Benz. 1994, MTU Friedrichshafen and Detroit Diesel began a cooperation on the development of series 2000 and 4000. 2002, joint management of the Daimler Chrysler off-highway business unit by MTU and Detroit Diesel off-highway. Tognum, Daimler's policy change in 2006, and they sold to MTU to a group called a private equity group, EQT, which established Tognum as a holding unit incorporating the MTU Friedrichshafen. That's where our headquarters are. And then the Decentral Energy Systems and CFC Solutions, and L'Orange, GmbH, and Rotor Union. Tognum shares were listed on 2007 on the stock exchange, which is the medium-sized companies on the DAX. And in 2012, which is still not here, Daimler-Benz has taken over again back Tognum and done a joint venture with a 50% with Rolls-Royce, as I mentioned earlier, both putting in all their engine business together to see that they get to the next step of technology and get ahead with their leadership in the engineering of engine business, actually. So this is basically the three units of division of Tognum. One is the engines, one is the on-site energy, and one is the components. The on-site energy, which is being represented today over here, includes the gas engine systems, the diesel engines, and the fuel cell systems. Fuel cell systems, we are currently changing that strategy, but basically we are enhancing and expanding very rapidly into the gas engine systems, and the diesel engine systems also we are using as decentralized energy systems for a very highly fuel efficient high-speed engines over here. So the products which Tognum does and the application areas, you have seen part of it in the film which we have shown today. So you have the on-site energy where we are supplying community, cities, developments. Then we are using prime power, continuous power, gas high-speed, medium-speed engines over here, airports, and gas engines, biogas engines, anything you say, whatever is gas-based concerned, we are doing it actually. Another, I thought before I end that, my appeal to the construction industry, you have to improve the quality of your construction, and you have to see that you do not waste energy, so you insulate your houses. Think about it, because the more energy you waste, the more you need for wasting that energy. Ladies and gentlemen, nobody would like to waste anything. Thank you very much here today and giving me this opportunity to speak to you.
Thank you, Dr. Khanna. And I think he has pushed ahead with the fact that MTU is at the forefront of that technology revolution and also providing the technology part of it. Solution is available, and we will have a few more of our colleagues talking about solution here. So with that, I would like to call our next speaker on the panel. May I request Mr. Rajesh Shah, President POP, Sterling and Wilson Limited, the Shapoorji Pallonji Group, to talk of energy efficiency of CCHPs, opportunity of India's urban energy need.
Good evening, everyone. I am Rajesh Shah from Sterling and Wilson. I come from a long background and a long innings with gas-based power and CHP plants. Before I begin with my presentation, I just want to answer a couple of questions, perhaps if possible. One issue is this $4 is expensive and $12 is not expensive. The best way to explain this is if you put a gas-based IPP, it is at maximum efficiency you can get is 50% NIPP, and by the time the power reaches the end user, it is at 35% efficiency. It is delivered at 35% efficiency. Now for that project, a $4 gas could be very expensive because he has pressure to supply power at a price which grid can afford. Whereas if you put a CHP plant on site, it is going to go at 85 and Dr. Khanna said sometimes at 95% efficiency. A $12 price can become very viable over there. So maybe I don't know if this satisfies, but this is the context where a $4 can be very expensive, and a $12. My second point is we talked a lot about natural gas. I have only simple point. We talked about cheaper financing. Perhaps what we need to do is very simple things. We need to ask a question: should gas be allocated to any IPP at all? For power generation. Because I just explained, by the time gas power reaches the end user, it is at 35% efficiency. So should we have any gas-based IPP at all? Or should, since we have scarcity of gas, if there was abundance gas, why not? Yeah, we can have a mix of everything. So till we have scarcity of gas, should the gas be allocated strictly for combined heat and power application? Yeah, that is perhaps an issue here which can solve. Whereas today in our policy in India, gas CHP does not figure on anywhere on the priority list. Yeah, it is combined with industrial use of gas. Yeah, and then you are on the last on the priority of gas utilization policy. Yeah, it is worst in certain states. If you use gas for steam generation in boiler, there is no VAT. Yeah, or you get back the VAT. You can. Whereas if you use a gas for CHP plant, you will have to pay 12% VAT on natural gas price. Yeah, so we are on a reverse completely. But India has grown not because any banks gave subsidy. Yeah. We have fantastic entrepreneurs who are willing to invest. If you see, I would say maybe 30, 40, 50,000 megawatts, 30,000 megawatts of captive power should be there in this country. I don't know the exact numbers today. And that has not happened because there was any enabling policy in this country. Yeah. That has simply happened because of the courage of the entrepreneurs and the industrialists. Yeah, and they need simple enabling factors, I would say, not very complex enabling. Before I go with my presentation, to ensure I am not boring people, I want to understand if there are any end users here who are evaluating or running a power plant. Yeah. If there aren't any and there are a whole lot of knowledgeable people here, then I will skip some of the slides here because then some of the basics is known by maybe all of you. Is there anyone here running a power plant or evaluating a power plant?
Just gone out actually.
Yeah?
Patel Infra is not here right now.
Okay, so then what I will do is I'll try to run through. I am bringing a case for commercial. So one of the solution which I will conclude at the end of my presentation. Yeah. What we want to say is we are seeing changing urban skyline. Yeah, in the city. Yeah. Things are moving in completely different direction for India, from India point of view, and is the electrical infrastructure moving along with these needs? Yeah, the urban. The challenge is put for the energy infrastructure is very high energy demands by the urban infrastructure. It is not just high energy demands, it is the quality of electrical infrastructure expected by the modern infrastructure. They want no compromise at all in any manner. If you see the kind of buildings or the kind of infrastructure that is coming up, zero compromise. 100% uptime needs increasing. There are projects which are coming, and if you see some of these buildings, because of the poor infrastructure that we have on electricity, the kind of investment which goes in to create this 100% uptime, yeah, is again, no one can say that we are short of money or we need any subsidy for finance. You have to go to any one of those buildings and see what kind of backup on backup is created, yeah, to get 100% uptime and to get clean energy is huge. You visit any data center, you visit any modern IT building, and you will see the kind of investment which goes into that. Yeah. So, and of course, cost of energy. Yeah. It is always important. But then in India, some of the people are forced to accept a higher cost of energy because the energy itself is important. Yeah. So this is a theme I am focusing on the building segment right now and trying to conclude what can be done.
Sure.
Oh, there is something. Okay, there is this has gone wrong. My what I can say is my animation has gone wrong. I've given you an example of a building. Typical power demand for a high-tech building is 7 watts per square foot, yeah, which includes air conditioning. Now, air conditioning chillers, just the chillers contribute about 25% of the power demand, and the auxiliaries of the aircon contribute 10%. Yeah, the total power 35% is towards air conditioning. Yeah, so the power demand, lead to growing. I will skip that. So current power infrastructure is shortfall is about 15% on peak. We can hear all kinds of numbers, but if you ask me, reality on peak is 15%, and the buildings operate on peak hours. Yeah, so that's why I picked up that somebody wants to have a peaking power plant, but again, an open cycle peaking power plant could be criminal on gas. Yeah, so one of the way to have a peaking power plant is all buildings on CHP, because they come online during peak hours. Now, what is a global trend? Again, I'm going wrong on my animation here. So, globally, as Dr. Khanna has also explained, CHP is extremely is a clear policy-driven tool for reducing carbon footprint. Is a major driver in Europe. Yeah. So Europe leading in CHP installations, followed by US. Today, Europe is far ahead in CHP. In Europe, where there is no scarcity of electric power, where any power cut will come up with a 1-year notice to you. Yeah, if they want to stop, if they want to discontinue or interrupt your power for 3 hours, they might give you up to 1-year notice that January or December next year, we are going to, in this time, we'll, in spite of that, CHP, most of them, if you ask MTU, if you ask any of the technology suppliers, that 80% of the business is done in Europe. Yeah, so that explains something. Reduction in, as I said, is a primary driver. So CHP with chilling reduces total power demand. It's very simple. As I said, 25% towards chillers in a building. Now, if you go CHP with chilling, you are knocking off 25% of your contract demand. Flat, simple. And we will show you how.
Now, for example, we have Mr. Khosla, who just entered from Patel.
Okay.
So they are into real estate and other things. And of course, we have DLF with us today. So I think at least 2 of your parties are there.
Okay.
Big ones,
So other benefits of CHP is, of course, you get reliability, quality of power, reducing, which will enable you to reduce the kind of panic backup which most of these buildings create. Yeah, so you finally end up reducing your overall investment. And if you ask developing countries, China is leading at 14% of their total energy on CHP. India is far away, less than 2%. Yeah, and that too in industries. On infrastructure, this concept is still nowhere. So that's where we are on the CHP map. CO2 emissions, if you see various options, the gas cogeneration is the lowest in grams of CO2 emitted per kWh energy generated. Yeah, so that is the driving force. If you don't look at this, I think for 2025, MTU Mercedes will have to design a bicycle for the CEOs in 2025, isn't it? There will be no way to ride your Mercedes, fuel inefficient Mercedes. Yeah. So these are, with this experience, with this infrastructure, we are leveraging, and we have created a gas cogen division about 6 months ago. Yeah. And we are a EPC contractor, so we want to give solutions to our customers. That's the game plan. We will evaluate a solution. We will mix gas turbines with gas engines. We will mix only gas engines. It can be anything. So we are not product pushers. Yeah. We will provide solutions. So with that, I would say that's it. Not much need to be talk about it. Yeah. Thank you very much.
It was a wonderful presentation, and Rajiv Bhai has thrown open a lot of things. He brought to fore economics of putting up such power plants of decentralized nature. Second, the question of whether it's, I would say, financially viable also came into account. Like he had a unique view. He said, first let us see whether we need to give any gas allocation at all to plants which do not operate in combined heat and power mode.